going to be talking about inclined planes. So on page 37 of your book, Basics of Perspective, it starts into some of the principles of inclined planes which we're going to discuss today. The general rule here is that when we're drawing either a 1-point perspective room or a 2-point perspective room, all the lines are going in 3 directions, straight up and down, or to the vanishing points, or parallel to the horizon line. When we introduce an inclined plane, what we're doing is we're producing basically a brand new vanishing point, which will always be directly above one of the vanishing points, either in your 2-point perspective or in your 1-point perspective. So we're going to do a 2-point perspective box, create a grid. So basically we're doing the same thing that we did last week. We're just going to create a room with a grid on it in 2-point perspective, and then we're going to create an inclined plane, which we're then going to turn into a set of stairs. So some examples of this are in your layout examples book, where in this instance here, we have an inclined plane, which is a set of stairs going up in this direction. We have a vanishing point. It's a single 1-point perspective. So you can see all the lines are radiating down to that single vanishing point right here. And then what you do is you project a line directly up above here to the inclined plane. Now, we'll talk about how to do this, but basically you just arbitrarily choose the inclined plane you want, or you can use a measurement system to decide how deep the stairs are going to be. And then this line, and this line all project to that vanishing point up above. The same thing applies if we're doing something in a down shot here, where we're at the top of the stairs looking down towards the bottom. We have an inclined plane here, and these lines are radiating down to a vanishing point, which is right down here. So once again, we'll discuss the different variations on this as we go along. So what I would like you to do is on your sheet of paper, we're going to place our horizon line. Again, the rule of thirds, we're placing our horizon line in the upper third section here. Across like this. Oops. We place our horizon line in the upper third, because again, based on our rule, when we're looking at people, usually we're aiming our angle, our camera angle is slightly down, so we see more ground than we do of sky. Not absolute 100% true all the time. Again, this just simply depends on how you shift your camera angle for your field of vision, your point of view that you're looking at something from. And so for the sake of just making this simple, what we'll do is we'll place a vanishing point over here on the edge of your sheet of paper and a vanishing point over here on this edge of the sheet of paper. And we're going to be drawing a 2-point perspective room. So if we go through the steps in our head, we have our horizon line, which establishes where our eye level is. We've placed it on our field of vision, which is our sheet of paper in the 1/3 position. We've selected our 2 vanishing points either side here, if this was to be more comfortable, and we can adjust our field of vision later on to a shorter field of vision like this. But if we were going to make the sheet of paper our field of vision, what we would do is we'd shove our vanishing points roughly about 2 inches off either side. So our next stage, when we're drawing our room, is we need to decide where what is. What's the next line that we're going to draw? If we're drawing a room, a corner. We select a corner. Because it's 2-point perspective. Because it's 2-point perspective means we're not looking straight on at a wall. We're looking in towards a corner. So we have to decide where are we going to place that corner within our field of vision. So we can place it dead center if we want to. And I'll leave this up to you. Okay, you can place it wherever you want. But you can place it dead center. You can place it over on the right-hand side, or you can place it over on the left-hand side. So I'm going to place mine roughly about here. So I'm just going to draw this line lightly down like this. I can go over with a ruler. And this line represents the corner of the room. So we have 2 lines drawn on our sheet of paper. We have a horizon line and we have the corner of a room. The corner of a room has to have a top and a bottom to it. It has to have an end point where the ceiling starts, and it has to have a bottom point where the floor begins. And so, once again, these are points that we have to make a decision on and decide, well, where exactly are we going to put these points? And that will define two different things. It'll define where our horizon line is in relationship to the corner, which then states this is our eye level. And then we have to decide what's the scale of the room. And then once we put those two numbers together, it tells us exactly how tall we are within the room. So if we go by the general rule that a room is 8 feet high, this line will represent 8 feet. So if we leave it exactly where it is right now, it's just slightly above the halfway point, which means that that's 4 feet right there, which means that this is approximately 4 feet 4 inches, roughly, off the ground. What I want you to do is I want you to select the horizon line at the 6 foot level on the wall. So 6 feet on this line. So you're wondering how to do that? Are you lost? We've drawn a line. We know that this is going to be 6 feet. That line is going to represent 6 feet on this line here. So the next question we have to ask ourselves is, how far away from the corner are we? Are we standing right in front of the corner, 2 inches away from it? In which case, both the top and the bottom would extend out of our field of vision. We wouldn't be able to see the ceiling or the floor because we're standing right in the corner. Are we 10 feet away from the corner? Are we 5 feet away from the corner? Are we 4 feet? Or 20 feet? You have to decide. So we use our own field of vision within an environment like this within the room and look at the corner and decide how far away are we. So how much ceiling do you want to see up here? How much floor do you want to see down here? I could just do this. There's my floor. The distance from here to here is now 6 feet. Okay. I just drew an endpoint and said that's going to be the floor. Okay. But if I extend my line down further, like this, I could also say that's the floor. And this now becomes 6 feet. Okay? So you simply have to make a visual decision. How much do you want to see? How close to the corner of the room are you? How far away? How much of the floor do you want to see within your field of vision? How much of the ceiling do you want to see within your field of vision? We know this is 6 feet. We know this is the corner of the room. Decide where the floor is. Pick a point. Okay? So once you've picked that point, let's say it's this point right here. Okay? This is now 6 feet. The distance from here to here is 6 feet. So half of that distance would be 3 feet. You guys are mathematical geniuses. At least one of you is. Okay, so if that's 3 feet, we now need to subdivide this by 3 in order to get our individual 1 foot distances. Okay, we just split it into thirds. So that now means that each of these increments here equals 1 foot. So if this is 1, 2, 3, 4, 5, 6 feet, we just have to take a measurement of one of these feet and stick 2 more on top. Or take 2 of them and stick the 2 on top, and ta-da! There's the top of my ceiling. Okay? So when you're doing your drawings, doesn't matter what it is, you have to make decisions. You have to decide what it is that you're going to be looking at. What do you want the people who are going to look at this drawing, what do you want them to think? What do you want them to feel? What do you want them to understand about the point of view that you've selected? And it's simply subdividing a line, making a decision once you place that line, wherever you've placed it within your field of vision, depending on what angle you're looking at that corner. Decide where's the floor, where's the ceiling, find your measurement, subdivide it up. All right? So now that we have our bottom point here and our top point here, we have 3 choices. We've selected one choice right here. We have 2 vanishing points. We have to go to our 2 vanishing points now. So now it becomes a game of connect the dots. For a vanishing point over here, you have to go through your corner up here. And since this is a room, the walls are coming towards us, so therefore we extend this line outside of our field of vision in this direction here. And then we do the same thing with the bottom down here. So based on the basic rule of perspective, the rule is that the closer something is to you, the larger it appears. The further away it is from you, the smaller it appears. So just by drawing 3 lines and our horizon line, and using our vanishing point over here, we've now presented a wall on this side that says this wall is coming towards us, because the distance here is less than the distance of a line if I was to place it over here. That wall is coming towards me. It's getting bigger. So now we do the same thing with the opposite vanishing point. And this now creates our second wall. So we now have the boundaries of our room. We have our floor down here. We have the wall on the left-hand side. We have the wall on the right-hand side. And we've got our ceiling up above us. So we've expended a huge amount of energy creating this room to this point. We've got 5 lines plus our horizon line and our 2 vanishing points. Whew, I'm tired. How about you guys? You want a break? You take a little 20-minute break just to recuperate from this? If you're not happy with what you've just drawn, select a new corner. Place your horizon line higher. Shift your corner over to the side. Make the line longer. Change the length of it. Adjust your vanishing points further out. Okay? It's all within your control to decide what it is you want to do at any given point in time whenever you're drawing something. So we're at this point right now, and I mean, for all intents and purposes, you're just basically following along with what I'm doing. Okay? So you're just going to blindly copy what I'm doing, and that's fine, nothing wrong with that, but you need to be actively thinking about what it is that you're doing as well. So you make a judgment call. You stop at this point and you say, do I like what I've drawn so far? If you don't like what you've drawn, change it. If you like what you've drawn, let's move forward. Right? So now that we've done this, what we need to do is create a little grid system, same as we did last time. And we've already subdivided our wall here into individual feet along here. Let's complete our grid along the wall, at least the radiating lines that are coming out along the wall. So at each 1 foot mark, draw a line out. Once again, try to be as accurate as you possibly can. If you're off by a little bit, it's not going to destroy things in a major way. Right, so now I've got my 2 planes blocked out. Now what I need to do is I need to create a grid that's coming across here. So we can do what we did before in our last class when we did the simple 1 point. I'm going to choose this wall to do first because it'll make things a little bit easier. Doing this wall over here, it's on a sharper angle towards us. So when things are flatter, it's easier to judge whether or not you've got your squares. Now, when I go to drop my lines on here, I can see pretty much immediately that my measurement lines are not all the same because my boxes are different sizes and turning into different shapes. But again, I'm not really absolutely too worried about that because it's just a rough system for blocking out my measurements. So I'm not going to try to be too anal about it. One of the major flaws that people have when they're drawing their 2-point perspective in that their vanishing points tend to be too close together, which with the fielding of this sheet of paper and my vanishing points being on the actual paper itself, we've got that illusion being created down here. You can see that on this corner here, this is a sharper than 90-degree angle down here. And so it tends to look like it's pulling awkwardly. That's because my vanishing point here If I can see that vanishing point, that means I'm looking straight on at that wall. If I'm looking straight on at that wall, then my lines across here should be parallel to the horizon line. But what's happening is they're bending, and so it pinches my perspective down here into a sharper than 90-degree angle. And that's not right. So in order to compensate for that, what I would have to do is I would have to change my field of vision to crop it like this on one side and like this. So this is the area that I'm actually looking at now. Okay, so I'm seeing less of the floor. I could extend it down a little bit further. But again, as soon as your boxes start to go to less than a 90-degree angle, you know you're in trouble and you've got to start pinching it. So I can get away with that pretty much as my fielding. Okay? So that's why I mentioned before that if you're using your entire sheet of paper as your overall field of vision, it's best to have your vanishing points off the page, right? At least about 2 inches off either side. All right, so what I have now is I have my wall over here gridded out, I have my wall on the right hand side gridded out, and I've got my floor gridded out. What I now want to do is, same as what we did last week, you remember we put boxes into our environment. What we're going to do this time is we're going to put a staircase in here. And in order to do that, we have to understand what's the dimension of our stairs. So does anybody know the approximate width of a normal set of stairs in a house? Anybody know how wide stairs are? Anybody know how wide a door is? Any guesses? 4 feet. 4 feet for a door?
No, for the stairs.
Oh, for the stairs. Well, what's the width of a door?
3 feet. 3 feet.
3 feet? Let's just move the camera around here so we can see the door.
What kind?
That's about 3 feet in width. Okay. So that door is 3 feet wide. It's abnormally high, obviously. Usually a set of stairs is just slightly wider than a doorway. Just slightly. So it's about 3.5 feet wide. So what we're going to do is we're going to put a set of stairs starting down here and going up to this level up here. So the stairs are going to incline up this way. So from the corner, we're going to put it right up against the wall. From this corner right here, we go across 1, 2, 3, plus a half. So we can draw a line down here. That's going to be the one edge of the stairs. And then we're going to extend our stairs out this way from the vanishing point along the floor. So I'm just simply going through this 3.5 foot mark here, vanishing point, extends the line across the floor. Now, if we want our stairs to be the same depth as they are high, which is not necessarily always true, but for the sake of simplicity, we'll do that. If our ceiling is 8 feet high, that means that our stairs have to be 8 feet deep. So we count out 1, 2, 3, 4, 5, 6, 7, 8. This would be the front edge of the stairs right there. All right? So they're actually going to extend off of my sheet of paper down here out of my field of vision. But this edge here would be the front bottom face of that first step. And so what I'm going to do now is draw my incline. Okay? And if I was just going to do this as a ramp, what I would do is I would select this point right here in the top corner along the wall and just lightly draw a line down there. That's the incline up against the wall. But there's something that I also have to remember, is that my stairs have risers on them, and if I want this to be the front bottom edge of my stair, I have to go up. I have to have the front face of my stair. So my incline can't start down here. It actually has to start at the high point of my top front step. and go to the high point of the back step over here. Right? So understand what it is that you're drawing and why you're drawing it. So if the distance from here to here is 1 foot, did anybody measure a stair height? The height of a stair? Nobody? How come? I asked you to. Man. 8 inches. 8 inches. So going from here to here is 1 foot. Half of that distance is 6. And halfway between that would be 8 inches. So that means that the height of my stair is going to be right there. Now, in order to make this clearer, I'm just going to stick another sheet of paper underneath here and just tape it into position, just so that we can draw through and you can see where the other part of the line is going to go. Let me just adjust my field of vision here. Like this. Okay, so I'm just going to draw through. This is all off screen down here. You're not going to see this. But just so that we understand what's going on. That's the corner closest to me of the stairs. So if we consider when we're drawing, there are 3 directions. Like even though we've got a set of inclined stairs here, there are only 3 directions that your lines can go in with 2-point perspective. To the vanishing point, to the vanishing point, or straight up and down. So right now I have 2 lines going off to the vanishing point. My only other option now for this line from this corner is to take a line straight up and down. So I line up my corner of my ruler here, find the line parallel along my grid here, which I can use this back line over here, and extend a line up. That now represents the corner of the front step closest to me in space. So I know this is 8 inches right here, so that connection point, I'm going to go from my vanishing point through this point here. And where that crisscrosses my vertical line that I just drew, that's the plane for the front step. So now what I need to do is I need to connect this corner here to the top corner of my stairs back here. So this little light line that I drew is really not a proper line. I'm just going to go back here and redraw this to the proper line, which goes right there. So that's the actual incline of my stairs. Now if I do the same thing on this side here, if I take from this point through to the top of the stairs on the wall there, that's the incline for that side. Now these 2 lines extend up and out of my field of vision. And I'm just going to show you this. If I just tilt this up a little bit here, you'll see that this line here is extending up like this. And when it gets to the point directly above this vanishing point right here, if I extend this up, it's actually the corner of my ruler there. If I put my finger right there and pivot my ruler, it connects through my corner here down to this point here. Did you guys hear angels singing?
I did.
It's incredible how that works, isn't it? See? It connects those 2 points. Right? Now this vanishing point here isn't really important. It's more just, ooh, isn't that cool that it actually goes up to there? Because when you find that out and you actually pivot on that point, there will be angels singing in your own house when you do it. But if you don't, they won't sing. But the important point is to know that you're going from this corner here to this corner here. And the width that you've chosen over here is going to be the same as the width over here. If you alter the width, if you make this width here smaller in your measurement scheme, then it's going to change your vanishing point and it'll shift your third vanishing point or your inclined plane vanishing point over this way. And what you'll actually hear will be something like this. That'll be little demons laughing, because they know that you've done something wrong. Okay? So whenever you do something wrong, the demons go, he's destroyed his drawing, I've won. Okay? But if you get it right, then the angels go, oh, this is beautiful. And that's what we want. We want angels singing when you draw. All right. So Now what we've done is we've created this incline. We've got the top riser on our first step. Now we need to build our steps, right? So we have to decide how deep is each step going to be. So if we use our mathematical equation that we had created before, being 8 inches, what we can do is we can go 8 inches in this way. So this is 1 foot from here to here. Half that distance is 6 and half of that would be 8. Right? So that gives our measurement this way, but our line connection is down here, not up here. Obviously we don't connect those two lines together. We have to drop a plumb line down here, and then from this corner, remember there are only 3 directions that you can go in. Right? You can go to the vanishing point that's over here, which we've already done with this face, from this corner. We've already gone straight up and down. The only other option we have is to go back to our vanishing point over here to create that top edge of our first step. So we project our line back in this direction like this. So that gives us 8 inches high by 8 inches deep, which is not actually accurate because steps are not 8 inches deep. They're actually deeper than they are high. So what we could do is we could arbitrarily just go to the 1 foot mark. And that way we don't have to keep dropping these little plumb lines down. We just know that we're going to go to this edge here. And then it's going to come across here. So let's see what happens here if we do this. If we take from this point here and go up to this point right here, okay, that would be the riser on the next step because of our inclined plane. It has to go to that point. If we don't, if we take the measurement that we have here and apply it to here, so we've got to get 8 inches on this point here. From here to here is 8 inches, there to there is 4 inches, so that's 4 inches there. We've got to go up another 4 inches, which is going to place the next point roughly about there, just slightly above our incline line, okay? Which is going to start to throw our incline off, which means that now if we connect those 2 points together, your incline is going to go up like this. So your stairs are going to end up here, which is going to be wrong. So we have to make some little tiny adjustments here in order to make it work properly. So the question here now is, you can use a measurement system, but my measurement system, as I mentioned before, is flawed right from the very beginning because I didn't accurately measure each of these. So these are not really 1 foot squares, they're sort of 1 foot squares, but not really. And so I run into the problem of my numbers are going to start going off. And as I continue this up like this, if I go across through that connection point there, back like this, and I go up to this next point here, my stairs are going to start to change slightly. They're going to start to get bigger as they go back further here. See, this one's getting bigger here. I go back to here. This one gets bigger up here. Go back to this point. See how big this stair is now? And I come to this point, and now I have the riser is 1 foot and 4 inches high, which may not work visually. But we're back to our piano key theory. Remember the piano keys? There are 88 keys on a piano. So if you only draw 77, nobody's going to notice the difference. So here, how many stairs have we got? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 stairs. Okay? That's a good number that at a glance, nobody's going to really notice. Okay? If you got 1 stair extra or 1 stair less, are they going to notice if the stairs are really that big a difference as far as the height goes? Probably not. So I think we're okay to stick with what we've started. Okay? So we'll use the 1 foot depth on each of them, let the riser tick off at this inclined plane, and we'll just stick with it and see what happens. Right? So let's go back to our vanishing point here. So we connect that point, and we're just drawing against the wall here now. So we're going to go up, then across to the vanishing point, the top of the next step, then up, to where it crisscrosses through that point there, back to the vanishing point. Okay, we don't even have to draw these lines here because they're already drawn, so we're just going to go through the crisscross points. just to speed things up a little bit. So there's our stairs now drawn along the wall. So now we've completed that one side. It's as though we've taken a piece of wood and we've gone and we cut that chunk of wall out there because, you know, theoretically we need a piece of wood actually that goes up against the wall like this. I don't know if you guys have ever built stairs before, but you need a piece of wood like this that's roughly about 2 inches wide on one side, and then you need that on the other side in order to place your pieces of wood for the riser and for the top step. Okay, you have to physically build it out of pieces of wood like this. So what we're going to do now is we're going to connect each of these corner points. Every time we see a corner, we know that it represents something, and we can go in 3 directions. We can go up and down, right? From this corner here, we can go up and down. We can go to the vanishing point over in this direction here, which we've done, or we can go from the vanishing point over here. So that's the only thing left to do on each of these steps here along the wall, is we've gone to the vanishing point over here and we've gone straight up and down. So now we got to utilize this vanishing point over here.